Right. Today we're reviewing for the exam. So for the calculus-based part of the exam, what will your question be? I ask you to make sure that you are aware.
Apparently those notes are in my other notebook, so I have no idea.
I looked at the practice exam from last year, for example. It has something to do with potential.
I'm going to assume it's center of mass and moment of inertia.
It's going to be one of those two things, yeah. Right? Those are the two things that are calculus-based that we can be prepared for. Right? With fluids, we haven't done anything with calculus yet. So that's all we have that you could have for your calculus-based question. So what I'm going to do is I'm going to give you an object, geometry that's reasonably simple. It may have a density that is constant. What's the term I'll use if it's a constant density? Okay, uniform, right? So I don't need to wait too long. If you don't know, I'm telling you because I want you to know what the test. If it says uniform, that means the density is constant. You don't need to raise your hand and say, what about the density of this? If it says uniform, you know the density is constant. So, Oksana. So the density is just, I'm sorry, I'm not OCD really, but I have to do this because I'll probably be OCD in another 10 years. I just noticed that two of these things are sticking out. All right, now we have that straight. What was I talking about? Okay, so if it says uniform, you know that it means that it has a constant density. If it doesn't say uniform, it is going to be a little bit harder, right? But what it's changing is the row you put in your calculation, and thus the integral has one more piece. Now I will try to choose something so the actual integration is not too difficult, right? I'm not shooting for hard stuff. I'm shooting for, do you know how to do it, and can you do, can you do the calculus? So, the equations at play are the equations on this slide. Center of mass, it's the weighted average of the mass's position, so you integrate the position of the mass, dm, divided by the integral dm. What's the integral dm by definition?
Rho dv.
Well, dm is rho dv, but there's a very simple definition that requires no knowledge except for what calculus is. What's the integral of dm? It's simpler than you're thinking. You'd have to know some things. Integral of dm. If I just gave you an integral, I said, what's the integral of dm?
1. Or m.
There we go. Right. So by definition, integral dm is m. The reason I put it this way in my equation, which is the same way it's going to show up on the equation sheet, is just to remind you that it's x dm over total m, and you get the total m with the same dm that you would get the integral of x dm. So then we have where you would jump to, well, dm is rho dv. Rho dv in 3 dimensions. In 2 dimensions, we'd put sigma dA. 1 dimension, we'd put lambda dx. But in all cases, the mass per unit something in space times the d that thing in space. So you prefer one-dimensionality.
Oh, yes.
And to do it one-dimensionally, all you have to do is have the density times the area times dx. Right? If you have like a uniform density, you can always do that. I didn't go through that. I figured leave that to the calculus people. Yeah, that's where
Okay, so basically that equation could be written as integral of x rho a dx over the integral of rho a dx.
Wow. Nice writing. I put dv, not dx.
Right, but dv
And
can be substituted down.
If everything works out as it often does, I say often because there are cases where it doesn't, a dx. If you have density changing along the area, you can't do that. It would have to be constant density on the area.
See, X center of mass stand for the X in front of them. It's like the point.
Okay, so x is a variable here. So you have an object. Let's say, well, let's do this once more for practice.
Please.
Let's give me a shape to find the center of mass of.
Square or cube.
Okay, I'm gonna make it not necessarily a cube, but have dimensions of A, B, C.
Cool.
Okay, now, what do we want the density to be? Uniform, or do we want it to be a function of something?
Can you eventually do both?
We could eventually do both. So you want to do it both ways.
I kind of do, because
Okay.
I feel like you're going to throw a curveball and put non-uniform density on test. I would be very pained if that happened, but
I don't want to cause you pain,
So
but then again, you're going to probably be pained if you take the test.
also true.
Okay, so if uniform is red, rho is constant, and so we have to define where our origin is. So where should we put the origin, right? These are problem might give you or it might not. So these are decisions you may or may not have to make, and so right now we're just making a problem up. Where should I put the origin?
I put it on the bottom left, like left of the A.
Right here?
I was thinking right at the A.
You were thinking here?
Yes, that.
Okay, Randy, you choose between those two. Don't give me a third option.
one half
I said.
B. Sure.
Okay. We had 2 votes for there, I think. Okay, and then we need to define our X, Y, and Z axes. I'm going to go ahead
Why
and
did you put it to the left of the A?
make X go like this,
Wouldn't matter too.
Y go like this. Yeah, it wouldn't matter. I was just asking where do you want to put it. That's
Oh, it doesn't matter?
it. If a problem says with respect to this location, then it matters.
Right.
If it doesn't, then it's your decision. And so in this case, we're making it up. So the problem didn't specify, so I let you make a decision. So here I have my X, Y, and Z coordinates. So let's say we want to do it a triple integral method. Triple integral method.
Oh yeah, this method.
dm equals rho dv equals rho dx dy dz. This is in Cartesian coordinates. I'm keeping it in Cartesian coordinates because I don't have a cylindrical symmetry, I don't have a spherical symmetry. Those are the reasons we can switch it, right?
Right.
So that's why I'm keeping it Cartesian, because otherwise Cartesian is the easiest. So if that's the case, I have dm, and rho was already given. All I have to do is determine my limits and do the integral.
Hold on, what happened to area?
I'm doing this the triple integral way, so we don't have area.
Oh, okay.
So I have 3 integrals, and then I have my rho, or actually, forgot the x, x rho dv equals triple integral. And this time I'll color code it like I did before. So in green, I'll have integral dz. What are the limits on z?
On Z?
I have y 2 times instead of c. That was genius. What are the limits on z? Goes from blank to blank.
It goes from 0 to
Yeah, 0 to c. And then I have integral dy. What's y going from?
Y is going from
Zero.
negative a to 0.
Do you guys see where he got that?
Yeah.
Picking it off from my picture. And then I have
Oh, yeah.
the integral of dx.
What's from 0 to b?
X to 0.
It's actually, it'd be 0 to minus b or minus b to 0, depending on which direction you're going. I'm going to go from minus b to 0. Right, because I had my origin was here in the front corner.
Yeah, can't you draw your x going into the board, though, if you wanted?
I could have. Didn't want to.
Okay.
I wanted to keep it a right-hand coordinate system. I wanted x coming out.
All right, cool.
It doesn't fundamentally change what you get for your answer. It just changes what the sign is. And, you know, any choice of origin is just going to be a translation.
Right.
Although in some cases it may make things easier or harder, and you want to choose the easiest. Okay, so then I have to have my integrand. So my integrand was x rho, and
Rho's
then
constant, so throw that out front.
okay, rho's a constant, so I can bring that out front. So I'm going to put the rho out here,
And then you leave your x with the
and
dx.
I already did the dx dy dz.
Right.
So that's my integral. Now the reason this is not difficult is because A, rho is constant, and B, we're completely uncoupled. That means that my z's are all just right there in my z integral. My y's are all just there in the y. No interrelation. So we just do these integrals. C equal, oh, and then we have to remember all divided by. So this is all divided by, and sometimes people will try to divide the integrals. That could be problematic.
Why do we need divided by rho?
Because that's the definition. The definition coming all the way over here.
Yes, you're right. I forgot that.
I forgot that because I got carried away.
And we still need to do the triple integral.
Yep. Whoops. Forgot to put a dy there. So there I have it all written out. Now notice my rows are going to cancel because it was a constant row. Once again, if it's not a constant row, that's not going to happen probably. Notice I have on top and bottom integral from 0 to c dz. What's the integral from 0 to c dz?
That's going to be the same thing as the bottom one, but that's actually going to be c and c, yeah.
I'll put the rows here just for completeness. So I have rho,
Why wouldn't they all cancel?
because they're not all the same.
Yeah.
Okay, what about the integral dy?
It's going to be positive a plus a.
And what about the integral of x dx?
X squared over 2. But then we got to do some fancy stuff. And there we go.
Right, you put the upper limit at 0, lower limit minus b squared is plus, so minus b squared over 2. What about on bottom?
It's just going to be x. No.
The integral is x, and you put in your limits.
Negative b.
Well, you have
Positive b.
positive b, right.
Minus. So your rho
So you
is
see
c.
this last one, Oksana, did not cancel.
Right.
Now we'll cancel everything that does cancel.
And these are all multiplied by each other?
Yeah. So what we have is minus b over 2. Now if we come back and look at our picture, that means it's somewhere on that plane. That's where the x center mass is.
Now we need to do that for.
And if we did the y center mass, based on what we just did, what would we get for the y center mass?
About halfway between A and B.
And if we did the z center mass,
Halfway through C.
okay, so we would have And where do they all meet? The center of the box. Right, so I mean, it's no shock how we got there, but the process is what we want to make sure we know how to do. Now, we said, what if the density isn't constant? So all of that was for constant density. Where did I put constant density?
It was up here, near the top, it was gray.
No. Oh, it was, I know, I started right there. Yeah, there. Is in red. Yeah. Okay, so that's if uniform, then density is constant. So let's change it now. So non-uniform. Let's say density, density is equal to, well, if I do it like this, what just happened?
You have a lot of integration to do.
Yes, I do. Life just got annoying because that is, you know, going to change with all the variables. I wouldn't give you something this complicated for the simple reason of it's going to take me 5 times longer to do the math. So what I would do is something like this. So what this is saying is density 0 at one side, and it's increasing as I go across. So if that's the case, I'm still going to have dm is equal to rho dx dy dz, but rho is now more complicated. It can't come out of my integral. So I'm going to have x center of mass is equal to integral from 0, and we're just putting the same limits, 0 to c minus a Okay, so that's just dv and the integral signs that I've written so far. So now I need to put in my x and rho. And then I have to remember to divide. And this time I am going to be well, I'll be even more clever and do this first.
This example, we can't move rho out.
That is correct. Now rho 0 is a constant. And so I can move rho 0. Whoops. Control Z, Control Z. Get off of the box. There we go. Now change it to green. So there I have my integral for center of mass. Notice I still had to have the rho on the bottom integral.
Sure. The dividing part is kind of like it was. So we have this, now there's different density variant. If it's uniform, it's just density. If it's not, we have
Right.
and then you divide the same thing essentially. And then we just did,
But it doesn't have the x.
but you solve or you cancel out the that.
Well, let me point out one thing, and then we solve. We can't cancel. So remember I said I'm doing it the triple integral way. What if I wanted to do it the single integral way? For the single integral way, I need a dx instead of dx dy dz. So what is the area that is the cross-sectional area normal to the x direction?
BC, or is it AC?
It's going to be AC. So the cross-sectional area is AC. Now let's look at what we got when we did this integral. This was C, that was A, that was the area. That was the cross-sectional area, was those first two integrals. So you're getting the cross-sectional area one way or the other. And if it's decoupled, it's simple. Now, if you're doing something like with spherical coordinates, it once again usually will decouple, and it's just as simple to do the triple integral as it is to do the single integral multiplied by a. Because we didn't have any sweat spent on the first two. There's only the third one. So now if I do these integrals, I'm going to have, just as before, rho 0 AC. That's a C. And then I have my red integral. So on the top, I have integral of x. What's the integral of x dx? Duh.
X squared over.
And then I have x times x, so x squared over x0 dx. If I multiply through x times x over x0,
Okay.
that gives me x squared over x0 dx. So what's the integral of x squared?
X cubed over.
And on bottom, integral of dx is x. Integral of x over x0 dx is x over 2x0, x squared over 2x0. So that was a little more complicated. Was it hard?
It's confusing. Like, I still don't really know what you did.
Okay, where do you not know what I did?
Like, why is x sub 0 counted?
Because that's a constant, right? X sub 0 is just some random number I choose.
I have no clue about that.
Okay, when it says x sub 0, it means this is a constant x, just
Okay.
some reference point.
That makes more sense.
That, do the thing where we just move it out and it's being multiplied by the entire equation.
X sub 0 is a constant for this term, and so it just stayed there. Didn't do anything, just stayed.
And then,
Although, if it's a constant and it's being taken the integration of, why isn't it being multiplied by x? Because when you take the integral of 2 dx,
Mhm.
you get 2x.
Integral of 2dx, you get 2x, right?
Right, so if
This is 1 over
is a
x0, and so it stays 1 over x0 multiplied by x cubed over 3.
over x.
That is what I did.
1 over x0, you get to over that. That's still constant times x.
Well, if it's over x0, then I have to multiply. Okay, so let's show that second integral. So the second integral is integral from minus b to 0 of, and I'll put everything. It was rho 0 x squared dx over x0. Right, that's what you get when you multiply
Yes.
this and that.
Yes.
And this. Don't forget the dx. And that. Don't forget the x.
Yeah. All right.
Okay, so when I multiplied those,
You forgot something.
well, I just took out this term. I was just doing the second part of the integral.
Oh.
So I had this x and this x made x squared on top,
Right.
rho 0 over x0, and then dx.
So why did we take out the 1?
Because I'm only doing, the way I do this in my head is I break it up into two integrals. I broke that integral up into oops, Mr. Rowe, well, equals rho 0 a c times integral from minus b to 0. Since I factor out the rho 0, I have to factor it out there. This is the way I think about this top integral.
Okay, so the rho sub 0 is taken out, and you have your integral of x. Okay, so that integral of x dx is the x times 1.
Right. And the integral of x squared over x0 dx
Is that.
is that one.
Okay, I get that.
Okay, so now I can take this 1 over x0 and put it out here if I like, because that was just a constant.
Oh.
Is it now coming
Yes.
clear?
Clear as mud.
Well, I mean, relatively speaking, we'll take that and go on.
Yes, okay, I get that now.
And I didn't show the there, it makes sense now mathematically. So now I just have to put in my limits, and I am going to cancel here. There's no reason to keep those along. So I put in my limits. Notice the upper limit on top and bottom is always going to give me 0 here because it's x in the numerator position.
Mm-hmm.
So I only have the lower limits to worry about. So I have minus b squared over 2 plus minus b cubed over 3x0 all over minus parenthesis minus b plus minus b squared over 2x0. First thing I'm going to do is cancel those leading minus signs. There's no reason to carry minuses on top and bottom when they cancel out.
Oh, okay, I see why you got those. All right, cool.
And so the first term is going to be a positive b squared over 2. Second term a negative b cubed over 3x0. I put the minus twice in case you didn't catch that. Bottom is going to be minus b plus b squared over 2x0. And I can factor out a b squared on top factor out a b on bottom
Shouldn't that be -1 plus b over?
You are correct, sir. Yeah, that's right. And now, of course, I will cancel one of these here, b's out front. I'm left with b times there's my answer. It was
I hope it's uniform.
Seriously. This is,
well, I was just going to say it wasn't that difficult. It's just the calculus was a little longer. So that's one of the two options we could have. The other option, finding the moment of inertia. So let's for a rectangular object like this, finding the moment of inertia actually is non-trivial because it's always going to be coupled. I will try to get you something so there is no coupling problem, right? Because that's just exacerbating your fun. So what I will do is give you fun. Yes, fun. I will give you something if it is the moment of inertia option that is either spherically symmetric or cylindrically symmetric, and have you find the moment of inertia about a specified axis. So to keep life interesting, let's see, what did we do? We did a thin circular disc. Yeah, which is basically a cylinder. I'm going to, for the purposes of today, do a cylinder with density not constant. But I'm going to make the density again. Let's see.
Are we going to be given the slides on the test?
The slides?
Not necessarily the slides, but the information on the slides. So I can scroll up.
You will be given this information.
That's all we'll be given. We're not going to be given the limits.
Right. You won't be given the limits. You have to figure those out. And it depends on the shape of your object, what they are. So it's not like I can give you, for this object, the limits are this, but that kind of takes away the thinking part. I mean, if this was a math class, I would give you all the numbers and say calculate it. But it's not a math class. Okay, so cylinder with rho equals rho 0 times 1 plus R. I didn't put R over R. Well, sure, why not? So it doesn't have to scale. Well, it has to have the right units anyway. So if that's the case, moment of inertia, I said ZZ. I didn't even specify. I just said ZZ. Huh, that's perfect. Cylinder. There's my cylinder. It'll have a height H, a radius R. That's all you need to specify, right? Just goes around the whole 2 pi radians for the angle. And we want to find the moment of inertia about its symmetry axis. I'm definitely going to have you do it about the symmetry axis. I'm not going to do something crazy. So if I want to do it about the symmetry axis, I have to determine specific things. First, I have to determine what coordinate system. Yes, it's cylindrical. SCYLINDRICAL. So dV is equal to, and you'll have this on the test. Cartesian, where did I have the cylindrical? Here it is. R dr d theta dz. All right. Then what is R perpendicular is the second question.
R perpendicular is R.
You are correct. Can you justify that?
Because that's what the slide said.
Because that's what the slide said. But if you were on some deserted island and had to reinvent everything, and you've heard that before, right?
No, but we'll go with it.
Yeah.
Carry on.
Yeah, could you come up with simplest technology on desert island? Ask that question all the time. Just for people to think of, okay, I've got some practical knowledge to actually do that, and I can get something useful. Could you make me live on a desert island? Yes. Okay, so R perpendicular is R because, what does R perpendicular mean?
The radius perpendicular to
The radius perpendicular to the axis of rotation. I mean, you were on right. I'm going to assume it was just words you had the idea.
And that makes sense because no matter what angle you kind of look at it, you can arrange
R.
R.
Is that
and
distance
always
away from the
perpendicular.
axis? Yeah. Because R is just measuring horizontally. You can go up or down, it's still horizontal. So that's why it's R. If you had a sphere, it's not R.
No.
Because the sphere, if it's at this angle, it's R, but if it's at this angle, it's going to be R sine theta, or R cosine theta, depends where you mean. It'd actually be, yeah, it's R sine theta. So here, theta is 90 degrees and it's R, but everywhere else is smaller. So we had to get that. Do you have a question?
No.
No, okay. Then we finally have the limits. That's the third question. And for our spherical coordinates, this is an easier question than it was even for our rectangular coordinates, our Cartesian coordinates. Because what does r go from?
R goes from 0 to R.
Right? Because it goes from the center axis out to the maximum radius. What does h go from?
0.
Or actually, I should have said y.
Oh.
Z.
Z goes from 0 to Y.
Z goes from 0 to h.
Yeah, that.
Because z was my vertical axis, and my vertical axis had a height of h. And so what did I do with this? I just assigned where my origin was. Previous to this, our origin just had to be somewhere on that z-axis. But now we define, okay, we're going to put the origin at the bottom of the z-axis. I could have gone, minus h over 2 to plus h over 2, minus 1/4 h to 3/4 h. I could have had all kinds of random choices. But let's make one of them 0.
Yes.
It does make your life more simple. And making the lower limit 0 makes it the simplest. Okay, and what about theta? This is why this one's easier.
Isn't that 0 to 2 pi?
Yeah, 0 to 2 pi. That's the one we don't have to think about at all. We don't have to look at the picture. If it's a complete cylinder, it goes 0 to 2 pi. And if it's not a complete cylinder, I'm not giving it to you. Was there a question, or was that just thinking it through? Now that we have that all together,
We once again do triple integration.
yeah.
Is there a problem with that? Or no, that was if it was covered, right?
So we have triple integral of r perpendicular squared dm, right?
What?
That's the I. That's the Senate. It's the I equation. Remember, you're going to have all of the equations that are on this page on the test. Well, you may not have this one because have we ever used that one? In practice, we haven't. I put that there just because if people are scared of a triple integral, they can do it that way. But as you've seen, it's not a big deal. So this is the equation I just wrote.
Okay. Or dm is still rho dv.
And dm is rho dv, and dv is this thing in the red box.
Which we will have on the exam.
Yes, which you will have on the exam.
Boy, no.
So this is equal to integral from 0 to h dz, integral from 0 to 2 pi d theta, integral from 0 to capital R. And notice I have it written right here. I don't need to go back. There was an R there, r dr, and then I just need my r perpendicular squared. Well, r perpendicular here was just r. So there I have r perpendicular squared.
But don't forget about your density. Because this one's not uniform.
Don't forget about the density. Thank you. That was part of dm. dm was rho dv. So we need times,
Rho. Which is 1 over 1 plus r over r.
wow, I almost screwed up majorly here. Appreciate you correcting me on that. Look, that was so easy and wrong. All right.
It would have been wrong if we had uniform density, though, would it?
That is correct.
Rho density.
We would have had the uniform answer because of mistake. Okay, so what's the integral of 0 to h, or 0, integral of dz from 0 to h?
8.
Bueno. What's the integral from 0 to 2 pi of d theta? Sehr gut. What is the integral from 0 to capital R of, notice that's r cubed, because r times r squared, r cubed dr times rho 0, 1 plus. Remember, I, in my mind, always break this off into two integrals.
Yes. So r cubed dr. What just happened?
R times r squared times r gave me r to the fourth.
Gotcha.
Right, so this thing in blue is a combination of the green and blue up above.
Right. Okay, so why did your P sub 0 go inside the parentheses there?
Because that's where it was above. Because it's a constant, it can come right through. So I can
But you have it in your other end.
I can move it out to here. And likewise, I can move those out to there. Same thing. Because they're constants, they can move through the integral.
Well, why did you need your P sub 0 in both ends?
Because it's multiplied by both of them.
Okay.
Randy.
When you started doing first in a row, from 0 to R,
Mm-hmm.
get that R times R squared is R cubed. Can you just leave the R there?
Let me just write this out. We have, if we multiply this through, we have dr, everything is multiplied by, right? Rho 0, everything is multiplied by. And then we have r times r squared is r cubed times 1, which is r cubed. And then we have r times r squared times r over r0, which is r to the 4th over r0. So there I've just distributed the r's. But I've kept what I can factor out that's not an r factored out. The reason I distributed the r's but didn't distribute the other things is because r is the variable in relation. So now the rho 0 can obviously come through because it's a constant. I have two integrals, one that has an r cubed dr, one that has an r to the 4th dr. And so that's why my thing down below, I broke up into the two separate integrals, one for the first term that has an r cubed, one for the second term that has an r to the 4th. And now I'm ready to do some integration. So, well, we've already done some integration. R cubed
R to the 4th.
r to the 4th
R to the 4th. What happened to your rows?
over
Your,
5,
yeah, 5.
the rho 0 to put out there. Okay, and if you want to try to simplify that, that's as simple as you can make it. It's not in terms of mass, though, is it?
No.
How can I make it in terms of mass?
You've got kind of a volume calculation out front.
But I actually have to calculate the mass by doing the integral like we did before, integral of dm. And then I could substitute, I take an integral of dm, and I would basically solve for rho 0 equals whatever the total mass is from that result. And then I substitute that rho 0 into here. I could even factor out rho 0h. I could solve for rho 0h. After that's going to be a little more complicated because of the nature. Okay, we are to the end of our class period. Review. What are you going to see for your calculus-based questions this afternoon?
Center of mass or inertia.
Find the center mass or mode of inertia. And if you can do what we did in class today, you'll be okay. Remember your steps. Any question?
Is this test droppable?
They're all droppable.
That's a good point.
I thought it was like the final or something like that. I don't want to take it.
Well, you can drop the final two. They're all droppable. You can only drop one, though.